Okay, so I was asking about one sample T. Anybody has any questions on one sample T?
Yes, Iman, I have a question. See, when we give a target less than 110, again we need to check on reducing the cycle whole time. What would be the effects on the quality? Should we have to do the other test again?
So this is just a kind of a directional tool which tells me that this is the target that I can take. If I want to also look at that my quality should also not be compromised, then probably I have to look at some other components. For that, there is no statistical test, okay? Because this is only on the continuous data that we have, and quality, if it's attribute set of a data, uh, then there is no test available for it. For that, we need to make a call, need to have a discussion around it, that I want to reduce the hold from 112 to 110. And then I also need to ensure that my quality should not get compromised. So that's a prerequisite that you can have along with it. But hold is something which you can reduce it to 110 at least with the help of this test using this example.
See, I'm talking about the injection molding of plastic components. See, when I reduce my cycle time, it is not that attributes are affecting it, even affects the dimensions. Then I need to take after setting the target of 110, again I need to collect the data and analyze on the quality again. How is it? How the
So
rejections are and everything. Again, I need to do the other tests, right?
yeah, so yes, you can do two combinations here as well. You can test with cycle time once, and then you can do it again as well. If you have two different sort of samples to look at, you can do in both the scenarios to look at whether both of them are showing equal results or not. But
Yeah.
when you say quality, it has to be continuous. This test is to be done when your Y is continuous. And when you're comparing Y continuous with any standard or any target which you're going to take, that should also be continuous. So likewise, in this case, we have taken whole time, okay, which is a continuous data. And in the hypothesis mean here, I mentioned 111, the target, which is 111 seconds or 111 minutes or 111 hours. Okay. So if you have quality percentage data or attribute data, then in that case, one sample T will not work. In that case, there is another test, which is one P test, one proportion test, but not one sample T test. Okay, so any questions on one sample T, the logic behind doing it, why are we doing it, and what is the purpose of doing it? Okay, similarly, there is a test called one sample sign or one sample Z. This test is to be done when your data is not normal. Okay, so you've already done the normality and you see that data is not normal. So in that case, stats non-parametric one sample sign. Here you take 18 seconds and here you see it's median here. Earlier you see there's a test mean. Here you can put, let's say 150. I don't know what's the average, so let's look at it and then we'll decide. So the median is 287 and I gave a target of 150. It says 0.057. It's a null hypothesis or alternate hypothesis?
Null.
It's a null hypothesis. It's a null hypothesis, which means 150 would be achieved very easily. You should take a lesser than that target. Okay. So let me put 145 because it was very, very near to 0.05. So I think 145 should show. So median is 287 and I have taken 145. Again 0.057, which means I have the capability to go below than that. So let's say I take 130, 0.02. Okay. So I have to decide that what is the bare minimum that I can take. I can mention 135. So that's how I can decide. Okay. So what I'm comparing 287, which is my performance, which has 62 samples, against the target that I have taken. If there is a significant difference between this number and this number, that is the kind of indication that I can take this target. Okay, so this is the same thing which we have done. It's just that in case of normal, I take one sample T. In case of not normal, I take one sample C. There's nothing major difference here. They are comparing the medians. In one sample, it was comparing the mean. Yeah. Okay, so now we have covered one sample T and one sample Z as well. Mann Whitney have covered modes, median, test of equal variance. So let's cover.
So, Simran, sorry to interrupt. Can you go back to that Minitab screen again? Thanks. So, how will you read this? Like, so conclude from this reading, like how your reading should be, like, or a conclusive statement or something, like how will you conclude to this reading then?
So before even concluding, you should know why we are doing it, and then only you will be able to conclude it. So do we know the purpose of doing this exercise? Can someone explain it to me and why we are doing it? Anybody?
So we are doing it to fix up a target to see if we are doing good or not, and what can be the target that we should actually try to achieve, that kind of a thing.
So first of all, we are not looking at whether we are doing good or not. Our purpose is not to check whether we are doing good or not. Our purpose is to check whatever the performance is. Whatever the performance is, what kind of a target am I capable to take against the performance that I have. Okay, that is something which I am trying to look at. So when I have some data, I would be able to calculate the mean or median out of it. It's very simple, right? You will be able to calculate the mean. Now let's say if the mean comes out to be 200, okay, which means 200 seconds or 200 minutes, which means the lesser the better. And obviously that you will be taking a target to improve, which should be below than what the actual performance is. Yes or no?
Right.
Okay, but you don't know how much target that you can take, which is something is kind of attainable. Okay, therefore you will do a one sample T or one sample Z, if and wherein you are comparing the actual performance mean with the mean of probably your choice, which you think can have, and then it compares the actual performance with the mean that you have taken. Okay, so here in this example, if you see, the median was 287, which is the actual performance. I haven't done anything,
right?
And I have given 135 as a target कि मैं 287 से 135 तक जा सकती हूँ. So this test is telling me if it is significant, if the p-value is lesser than 0.05, which means it's alternate hypothesis, which says that yes, it can go, which means 287 is not equal to 135. It is saying not equal.
Right.
If it says
right.
alternate, if it says null hypothesis, which means 287 is equal to 135, wherein Minitab is saying that this target is easily achievable over a period of time. Since the process get matured, it would easily be achievable. So there is no need to do a project. You should take a target lower than that. That is what it is telling me.
So there will be lots of trial and error before we arrive at a particular target, right?
Yeah, you should come up as a bare minimum target and probably give a range that this is something which is the bare that we can take, and the rest is a management who can decide, because this is not a decision making tool. This is just a directional tool. I cannot make any sort of a decision, but yes, it just gave me an indication that yes, this is something which I can consider.
Why don't we take simply the mean and some combination of mean and variance, or median and variance to get to a target, rather than having this test repeated, repeated.
Simar, my question is on the same lines. My question is, one sample Z is much better in a non-normal data, because in a huge data set, we can't compare the median of it. But in one sample T, when the data is normal, it's pretty easy, even looking at big data, to decide on a target. So in my view, one sample Z gives us much more insight, because you can't compare the median of 287. If you just look at that and you decide a target of 250, that's not going to be the right one. So this is comparing the median of 135. So this is giving me more insights than one sample T.
So the answer is absolutely correct, because one sample Z has median into consideration, which eliminates the extreme values that has in it. However, the question that you asked, yes, it doesn't take the variance part. It only takes the average. It only takes the average into consideration, which clearly decides at what sort of a target that I can go for. Yes, but so that's what I'm saying. It's not a decision-making tool. It's a directional tool.
Yeah.
We have to. So likewise, Ashwini was saying that we can look at the quality as well. We can look at the variance as well. So these are the things that you can think of. Probably you can take some additional checks to do that. But this test will only tells me what am I capable of performing.